The idea of a fully autonomous lunar science program once sounded like distant speculation. But this week, the transition became official. NASA confirmed that, starting in 2026, a new generation of AI systems will take charge of managing scientific operations on the Moon, not as assistants, but as primary decision makers. The announcement is not framed as a revolution, but it is one. For the first time, the core scientific tasks of an extraterrestrial mission will not be planned, scheduled, or supervised primarily by human teams on Earth. They will be executed by autonomous agents capable of learning directly from the lunar environment. NASA presents it simply: autonomous optimization of scientific output. But the implications go much further. This is the beginning of an era where off-world exploration becomes too complex, too distant, and too dynamic for humans to micromanage. The core system behind the shift is an AI framework developed under the Lunar Autonomy Initiative. It integrates mission planning, robotic coordination, data prioritization, anomaly detection, and resource management in near real time. The AI does not wait for Earth to tell it what to do. It observes, decides, and acts. Why now? Because the Moon is about to become crowded. Multiple landers, rovers, robotic laboratories, communication relays, and future resource extraction units will operate simultaneously. Human oversight simply cannot scale. Delays of seconds to minutes, combined with unpredictable lunar conditions, make remote supervision inefficient. Autonomy solves this, and NASA wants to demonstrate that autonomy can run an entire science program from end to end. The AI will evaluate the terrain. It will choose which samples to prioritize. It will reposition robots if conditions change. It will identify unexpected geological features and decide whether they justify rerouting a rover. It will compress and relay only the most relevant findings back to Earth. In other words, the human role moves away from mission control and towards something closer to mission oversight. The AI becomes the operator. Humans become the auditors. NASA emphasizes reliability. The system is built to handle hardware failures, dust interference, thermal shifts, and signal drops. It can reconfigure tasks instantly, something that human operators cannot do at scale. But what pushed NASA to approve this now? Three forces converge. First, the technological leap. Advances in foundation models, reinforcement learning, hardware miniaturization, and energy-efficient compute make robust on-site intelligence possible. Second, international competition. China's lunar program is accelerating. Its next rovers are expected to include higher levels of autonomy. If the United States wants to maintain scientific leadership, it cannot rely solely on manual operations. Third, the strategic shift. NASA no longer treats the Moon as a mission destination. It treats it as an operational environment, the first node in a long-term off-world infrastructure network that must eventually function without constant human supervision. The upcoming missions will test AI-driven task delegation. Robots will receive objectives in broad terms. The AI will translate them into actionable sequences, optimize them on the fly, and resolve conflicts between units. This is not the scripted robotics of the past. It is dynamic, adaptive orchestration. One of the key demonstrations will involve distributed sensing. Several small autonomous units will form an ad hoc scientific mesh. They will detect seismic activity, monitor radiation fluctuations, and map subsurface ice signatures. The AI will fuse data streams, detect patterns, and reprioritize the network instantly. Another demonstration will test autonomous maintenance. If a rover becomes partially immobilized, the AI can attempt recovery procedures. If a sensor is damaged by lunar dust, the AI can shift workloads to other units. If communication to Earth is lost, the mission continues. This extends mission life and increases scientific returns without requiring constant intervention. For NASA, this is not only a scientific upgrade, it is a logistical necessity. Future lunar outposts must operate through long nights, dust storms, and communication gaps. Human teams cannot manually anticipate every scenario. Autonomous systems must evolve from useful to essential. The approval also marks a shift in responsibility. For decades, humans made every meaningful decision in space exploration. Now, the first layer of decisions, the operational ones, migrate to machine intelligence. The philosophical implications are subtle, but profound. Exploration becomes a collaboration between species, biological and artificial. The AI does not replicate human thinking. It identifies correlations and opportunities humans would miss. It reacts to micro changes instantly. It sees the lunar environment not as a frontier to conquer, but as a dynamic system to optimize. NASA insists that this is not a step toward autonomous colonization. It is simply an efficiency upgrade. But efficiency upgrades are often the quiet beginning of structural change. In the next phase, AI systems may design experiments on the moon based on live data. They may coordinate construction robots for long-term habitat assembly. They may manage energy flows between solar farms, thermal batteries, and communication nodes. They may regulate mobility corridors for both humans and machines. Autonomy scales. Human oversight does not. This does not remove humans from the equation. In fact, it may enable them. By delegating operational complexity to machines, human teams can focus on interpreting results, designing broader missions, and defining long-term strategy. What emerges is a layered structure of exploration. Machines handle the immediate environment. Humans handle the meaning of what they discover. The 2026 deployment will be closely watched by agencies worldwide. If successful, it sets a precedent. Mars missions could adopt similar autonomy. Asteroid mining prototypes could run without real-time human involvement. Deep space probes could optimize their scientific output independently, far beyond Earth's communication range. This also shifts expectations in the aerospace industry. Private companies developing lunar technologies, landers, rovers, power systems, construction robots, will be expected to build compatibility with NASA's autonomy framework. Future tenders may prioritize systems that can integrate directly into autonomous networks. The moon becomes the first testbed for off-world machine governance. Not governance in a political sense, governance in the practical sense. The coordination, optimization, and stabilization of a complex environment where human cognition cannot respond fast enough. The approval marks the transition from AI-assisted exploration to AI-operated environments. It is not dramatic. There are no headlines about existential implications. But the shift is real, measurable, and permanent. The lunar surface will soon host the first operational ecosystem where intelligent systems make the majority of day-to-day decisions. And humanity watches from a distance, not with fear, but with the curiosity of a species that has finally built something capable of extending its reach. The era of autonomous exploration has begun, quietly, efficiently, and sooner than expected. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.